Today, we are diving deep into a problem that, let's be honest, trips up even the sharpest tech teams out there, the AI testing trap. We're going to look at why the old ways of doing things just don't work for AI, and more importantly, how you can A/B test your systems the right way. So, if you've been in the software world for a while, you probably feel like you've got A/B testing down to a science. But here's the thing you have to understand. When AI gets into the mix, the old rules don't just bend, they shatter. And this slide really says it all, doesn't it? Traditional software, well, it's predictable. When it breaks, the failures are usually contained. But AI systems, they are a whole different beast. They're unpredictable by their very nature. Failures can be incredibly complex, and they can cause really weird user behaviors, like this thing called the novelty effect, which can totally trick you. You can get a huge win on one metric, while completely behind the scenes, you're causing a catastrophic failure somewhere else. Okay, so here's our game plan for getting through this minefield. First, we'll pinpoint why these tests go wrong. Then, we'll lay out a 6-part success plan. We'll get into how to test smarter and faster, how to build in safety nets, how to dodge that new and shiny trap, and we'll wrap up with the essential math that makes the whole thing trustworthy. So how in the world do we deal with all this complexity? Well, let's get right into the solution. And this isn't just a handful of tips, it's a complete blueprint. Think of this as your playbook for running AI tests with the kind of rigor they really truly demand. There are 6, count them, 6 critical things that you absolutely, positively have to define before you collect a single byte of data. And that's the whole point, right? If you don't lock this stuff down first, you're just winging it, and that leaves the door wide open for all sorts of bias to creep in. Let's just walk through them really quick. You need crystal clear objectives, like what decision are you actually trying to make with this test? You need to document everything beforehand. You've got to design the methodology, plan how you'll manage the data, define your entire analysis plan down to the exact statistical tests you'll run, and finally, figure out how you'll communicate the results. The real power here is that this whole process stops you from moving the goalposts halfway through the game just because you don't like the score. And check this out. This is a perfect example of what a great objective looks like in the wild. It's not some vague goal. It says exactly what to evaluate. Reduce false positive rate without degrading true positive rate. It's specific, it's measurable, and it has a clear definition of success. This is the kind of clarity you should be aiming for. Okay, so once you have that super rigorous foundation in place, you can start to optimize. You can get faster, more efficient. And that's where this really powerful technique called sequential testing comes into play. So with a traditional test, you have to wait for all the data to come in before you can look at it. But sequential testing lets you peek as you go. Now, the trick is you have to decide on your stopping rules ahead of time. But if you do that, you can stop the test the second you have a clear winner or a clear loser. This saves a ton of time and, just as importantly, it means fewer of your users are exposed to a potentially bad experience. And believe me, this isn't just theory. There was a fintech team testing a new compliance model. They had planned for a full 8-week test, but because they used sequential testing with clear stopping rules, they got a conclusive result in just 3 weeks. That's 5 weeks of engineering time and data collection that they just got back. Amazing. This next part is, well, it's absolutely crucial. This is your safety check. It's awesome if you get a big win on your main goal, but what if you totally broke something else along the way? This is all about making sure that doesn't happen. I just love this rule because it's so simple and powerful. Your primary metric might be screaming, go, ship it, but your guardrail metrics are the bouncers at the door. If you violate a guardrail, if latency goes up, or you introduce some kind of safety risk, the test is a fail. End of story. So, what kind of stuff should you be guarding? Well, think about safety. Is the new model producing more harmful content? What about user experience? Is it slower? Then there's business protection. Are you accidentally killing your conversion rate? And of course, compliance. Are you staying inside all the legal lines? You've got to define these up front. All right, now for one of the sneakiest, most common traps in AI A/B testing. It's called the novelty effect, and it's so easy to fall for it if you're not careful. The novelty effect is just what it sounds like. Users engage with something new just because it's new. Imagine you roll out a new chatbot that's way more talkative. For the first week, people might love it. It feels so engaging. But after a few weeks, they might start to find it exhausting. The initial positive signal was just an illusion created by the newness. And this chart, wow. This chart tells the whole story.
If you stopped your test after 1 week, you'd ship that new version, pop the champagne, and be totally convinced you had a winner. But if you just let it run for 6 weeks, you'd see the truth. The excitement fizzled out, and the old version was actually better in the long run. This is exactly why short tests can be so dangerous with AI.
So how do you fight this? First, run your tests long enough. 3 to 4 weeks is a good minimum. Second, you have to plot your metrics over time. If you see that initial leads start to shrink week after week, that's the novelty effect dying right in front of you. And for really critical systems, you might even consider a long-term holdout group to see how things play out over months, not just weeks. Okay, on to our final section. And hey, don't let the word math freak you out. This isn't about memorizing formulas. It's about doing the foundational work that proves your results actually mean something. This is what turns a guess into a confident conclusion. First up is something called statistical power. To put it simply, it's the probability that your test will actually spot an improvement if a real improvement is there. If your test is underpowered, you could have a genuinely better model and completely miss it. You just conclude there's no difference, when really you just failed to detect it. And getting enough power can take a huge sample size. I mean, look at this. To reliably detect just a tiny 1% improvement in accuracy, you might need over 16,000 samples. That's why you have to do this power analysis before you start, so you know if your test is even possible to run. And here's a fantastic pro tip for any test that involves human raters. Before you even start, get your raters together, have them score a few examples, and talk through it to get on the same page. These little calibration sessions can improve their agreement by 10 to 20%. And why does that matter? Well, better agreement means less noise in your data, which means you need a smaller sample size to get a result you can trust. It's a massive win for efficiency. So let's bring it all home. If you remember nothing else, remember this 5-point checklist. 1, always specify your 6-part plan before you start. 2, use guardrails as hard, non-negotiable rules. 3, run your tests long enough to get past the novelty effect. 4, do the power analysis to make sure your test isn't a waste of time. And 5, if you're using people, for goodness sakes, calibrate your raters. And that really brings us to the final question you've got to ask yourself. The teams that actually follow this playbook, they build systems they can really stand behind. So take a hard look at your own process. Is it building real, lasting confidence, or is it just creating a very convincing illusion of progress?